nice. I hope it's recording. Okay, so we are going to start with the decision tree classifier. Now, like I explained before, please, when it comes to using all these other classification models, they work best with classification. So when it's something to do with regression, you know the models to run to. So in this case, we are going to continue working with our data point for the churn analysis. And I think now, for now, you are mature as far as building a machine classification model is concerned, or as far as performing customer churn analysis is concerned. And you now want to see how this decision tree will lead us up to making a decision and also classifying a sample data into a no class. Of course, at a certain percentage of accuracy. So we import pandas, numpy, and SAS and multiplot library. Not It is actually it is. This app always have some meaning, but once you see this red thing doing that way, you get to go sour. So the Sanskrit learn dot model selection where we import Trent and Split and grid search CV. Maybe you can remind this forgetful tutor what grid search CV does. Okay, grid search CV is used to perform hyperparameter tuning. Yeah, to find the best hyperparameter. For example, if for the specific classification task, it's used for classification, by the way. So it is used to find the best parameter for a classification task. That if it is a k nearest neighbor, it will be used to find the best k. If it is decision tree, it will be used to find the best depth or height of the decision tree. Hakuna vile tunaweza ita, ni hivyo tu. Then we import another scaler. Scaling data is mostly required for those points that basically do not need classification, like support vector machines. So I don't think if you need it here, but later, that's why I've not used it. Then from Sanskrit-learn.tree, you import decision tree classifier. That's why it's imported from Sanskrit-learn. Then from Sanskrit-learn.metrics, we import the following: accuracy score, precision score, recall, F1 score, and confusion matrix and classification report, which we are going to work with. Like confusion matrix and classification report will help us in ensemble learning. Then we can also plot the tree, like the decision tree itself. Can be plotted by importing plot tree and see, and you will see it how beautiful it always is. How beautiful it always is. I guess that's the correct English. Then we import joblib, which is used to save the model in our local environment. Once you are certain or sure that this model is the one that I want to deploy, you save it in your local environment. You will see when the right time comes, and it is mid this month, we shall deploy one model. Then logging, which allows you to see the problems. It's mostly used for production environment, and it has helped me a lot with MarketShed app. When something doesn't work as intended, I just go to logging and I'm able to see that the server stopped at point this. Then you restart the server and I'm like, okay, thank God it always stop when it is idle. So saa sita usiku watu wakianza kuitumia inarudi mwenyewe. Random seed for that one. Then we import the data, and the data, we had gone through it. We had seen the different types. It had some categorical data. It also had some like the data was actually a very good data that can be used for analysis. It was from a telecommunication company, and you can use it to, based on all these details here, you can use it to predict maybe if whether customer will churn out or not. So then we set up logging. So that's the logging.basic configuration. We just need information, the basic information. Pre-processing, I don't think if I need to repeat anything to do with this. Yeah, so we just need to ensure that we change total charges to numeric, because it was an object, it was picked as objects. And that's why before we do anything here, it was very, very instrumental to do df.info. Very important. so that you are able to see. No, no, no. df.info in bracket. So you are able to see that one will be an object, payment method, total charges. As you can see, oh, it has now been changed to float, so it's okay. Then we also fill the null values with median. Remember what we did? And we also drop the customer ID axis twice in column wise because we are not going to use it. Then we select all the categorical features, then change them to a list. Then we remove from the categorical features, we remove the chan. Why are you removing the chan? Yeah, and sorry, I forgot I was teaching Shak. So then df, then we get dummies. To get dummies, do you remember what it was doing before? Yeah, if it was male, it was just going to transform gender male. Then if it is not male, if it is male, it's 1. If it is not male, it's 0. But it's going to assume the female. Why is it assuming the female? Because there is no need of doing gender female when in real sense, the opposite of gender male is gender female. So when you put gender male as 1, automatically gender female becomes 0. So that's what dummy variables is. So with all this, we've done some comprehensive data cleaning. When I was learning to do the science, I used to do this. Df total charges is equal to p dot numeric. Error is equal to coes full stop. Df is equal net total charges dot median. You calculate median first. Then you come again. Df total charges dot. Now you call. Let's say like here I used to give it to assign it to a variable. Total charges median is equals to df total charges dot median. And then you say total charges median dot fill NA. Yeah, so it was like all that process. But when I realized something called this is called method chaining in Python. You can use up to 10 methods in a single line. From then, I've just been living in a milk oil. Have you ever tasted the milk oil from your grandmother? That thing slaps. People just there is some pure greatness in that milk oil, or I just know how to call it in my mother tongue, but in English, let me just call it milk oil. So sweet. Okay, then also as you can see, we've also done some method chaining here. What it does, and now we have the clean data. Once you're certain that your data is clean and ready for analysis, you do what? You select all the x variables and the y variables. I should not be explaining this. We've been seeing about this, and also split it at 80 to 80/20. Then logging.info data split 5656 training and 1409 testing. And how did we find that? We used the f string method to note it down, where we can now use curly braces into bracket length of x string. Just length will just tell you the number of rows in that splitted data set. And yep, now we can implement our decision tree classifier. But again, we do grid search. For example, first of all, we look at the parameters. The decision tree parameters, for example, maximum depth can be 3, 5, or 10. So uh, the program is going to evaluate between 3, 5, and 10, which is the best. Yep, this is hyperparameter tuning. Thank you, making my work easier. It's like two men who are moving concrete up to the fourth floor. Another one just goes and puts it in. You see that machine that pulls it with something like a dot going up. And another one says that that is a lot of work and starts carrying it on his back. So for you to me, like what you're doing to me is like the machine. Very. Then the minimum sample split. The minimum sample splits is actually the number of samples you are going to split the root node, the decision node, and also the leaf node. Okay, the root node and the decision node. So we are going to see if we are going to split it 2 times or into 5 samples or into 10 samples. Of course, the grid search is going to help us do that. And now you use the grid search CV. This training takes about around, yep, CV search. Then you implement it in decision tree classifier with random set 42 and use the decision tree parameters. Uh, do it in 5 iterations. Yeah. Then scoring, use accuracy score, then the number of jobs is equal to -1. Last time when we looked at decision tree, we said that the number of jobs is equal to, let's just revisit it so that we don't miss a point there. Sklearn decision tree. We have to give much credit to the Sklearn community for this. It has helped a lot of businesses, by the way. Hey. Classification, decision tree classifier. So these are the parameters. If you don't understand anything, just please come to the parameters. They will teach you what you need to know. And in fact, I highly implore, especially if you're a senior data scientist, don't just implement decision tree classifier into brackets because classification is being implemented. That is wrong. For a senior data scientist, you must specify maximum depth and minimum sample split. If you leave it, if you leave it as a default, the Sklearn will pick all these. And you see, this is not what your business require. Your business might have its own specific requirements, and that's why performing CV search or grid search is very, very much important in this task. So if you're not sure, just come. Read criterion, Gini, entropy law. This is the function to measure the quality of the split. Supported criteria are Gini for the Gini impurity and log loss, and entropy both for Shannon information again. If you are not sure what these things are saying, just open the mathematical formulation. But in this case, I highly recommend you leave it as default. The splitter, let it be default of split. So maximum depth, this is where you start now working. Please perform a grid CV search. The maximum depth of all tree, if none, the nodes are expanded until all leaves are pure or until all leaves contain less than minimum sample split samples. So you can perform research or just leave it to none so that it does it that way. But again, if you are a data scientist who is also where in operation ML ops engineering, what we are doing, you realize that we must also try and understand as our operations need. We should not implement a model that's going to eat much into our memory. So what do? We do grid search to find the best. Then the minimum sample split, the minimum number of samples required to split an internal node. If integer, then consider minimum sample split as the minimum number. If lot, then the minimum is a fraction. Hey, very background noise. The default is 2. Of course, we always use the default of 2 so that you start just splitting into 2 parts, like making decision, splitting the samples into 2 parts. Minimum samples leave default is 1. There are others like number of jobs. So, you see it somewhere, tell me. Let's see, am I grid search? Oh, that is under grid search CV. You see, the decision tree classifier had been stopped at random state at 42. So it is using all the random. So first of all, it is using the maximum depth to be none, meaning it will do everything until we are done. But this is it is encapsulated by this grid search CV, which we can search for. Grid search CV ni iteration to, like, inajaribu tu kupata the best combination that works. And the following: eliminator, parameter grid, scoring number of jobs. Here it is. The number of jobs run in parallel. None means one unless job leave parallel or something like that. Then context. -1 means using all the processors. Uh, this is basically the implementation of the model, like during the training of the model. How many when maybe you have the splits have happened, how many jobs do you want to run? So in this case, they say if you use none, it means one. But now -1 means using all processors. So that's why we've used -1 in our case. Then data degree that we define actually all these functionality, we assigned it back to decision tree grid. DT means decision tree. Then now we fit it. Having found the best one, from this we are able to find the best combination, by the way. We now fit it on X train and Y train. Then the model is the one that gives us the best estimator. The best estimator is gotten when you try. Uh, Nice. The best estimator is actually realized when you do the iteration we're talking about 3 and 2, 3 and 5, 3 and 10. Full stop. 5 and 2, 5 and 5, 5 and 10, 10 and 2, 10 and 5, 10 and 10. Then under that we now find the accuracy score. From the accuracy score, that is the best estimator of all those estimates. Then is the one that we choose. So once we did that, we now evaluate and we find out that the accuracy score of the best estimator is the one with parameters maximum depth to be 3 and minimum sample splits to be 2. So then the accuracy score is 0.78. So we are slightly, like very slight. But again, another thing, I said you can deploy it, then monitor. Kama unafanya kazi vibaya, you pull it out of the new. Because sometimes you can also, by the way, it can underperform here, then in the production environment it performs fine. That's also possible. Yeah. Ulikuwa umesuggest ati customer based on the previous customer behavior. Huyu customer alishinda akipigia customer care simu kila saa, akaquit at last minute. Mwingine akakuja akabehave kama yeye pia akaquit. So the model is working perfectly. The machine learning model, by the way, its reasoning is just how human reason. It's just that we are using data to train that reasoning. Let's now plot the tree. Plot the tree, and as you can see, we use a PLT figure, then implement plot tree on the DT model. But the DT model is the one with the best estimator, and the one with the best estimator is maximum depth 3 and minimum samples of 2 at accuracy score of 78.71%. Then feature names is equal to X columns. And what do you remember of X columns? The X columns were the columns which had categorical which had features other than Chan. Then the class name is either yes or no. Then the field is true, then maximum and depth is 3. You only get this maximum depth when you when you've done grid search CV up there. Then plt.tree, this is optional but highly recommended. Then you save the figure and show it. Let's see. This client, the Gini sample is 0.9. The samples are 5634 that have been used. The training sample, that is the class of no. This client, the tenure is less than 16.5. Let's see. The class is no. And where did we find no? Okay, we are going to see it down here when we classified an example. So we are using a pseudo class of no. Equate. For example, we want to make decision. This client had been with us for less than 16 years, but at last minute he quit. Did he quit? True. Yes, he did. False. He did not. When he quit, what were the problems? The internet service of the fiber optic was less than 0.5. Is it true it happened? Yes. So at the end of the day, we moved until we find the decision criterion. But the best place where we can explain this decision tree is when we visit the plot tree in research CV. Ah, Jesus. This is it. So in the decision tree, this is the model that you just built. This is the model. The decision tree to be plotted, the model that you just built. The maximum depth should be the one that you found out during research CV. Then others, I think others can be left as, and others can be left as default. So the tree structure, the decision classifies an attribute called tree underscore, which allows access to low-level attributes such as node count, the total number of nodes, and maximum depth, the maximum depth of the tree. The tree underscore dot compute node depth method computes the depth of each node in the tree. So there's a lot of nodes here. I just wanted the example. Here we are. So we have these three decision paths. We can also retrieve the decision path of samples of interest. The decision path method outputs an indicator matrix that allows us to retrieve the nodes. Nope. That's not what I want. Okay, this is what we do in real world example. You build a model and you're struggling with explanation, just come and search for explaining decision results. I don't want to change colors. Good. This is the guy who helped us a lot before the onset of AI. Yeah, so I have two problems with understanding the result of decision tree from Sanskrit. And for example, this is one of my decision tree. Yeah, this is the what we wanted. My question is, how can I use the tree? this man is honest. So the first question is that if a sample satisfies the condition, then it goes to the left branch if it exists. Otherwise, it goes to right. So let's find an example. The four answers. The first one, the value line in each box is telling you how many samples are that not fall into each category in order. That's why in each box, the numbers in value add up to the number shown in the sample. The value in each box is telling you how many samples at that node fall in each category. The samples. Okay, so these values in this node falls in that category of yes or no from the samples of 11,200. Let me find someone who has explained to. Mm-hmm. Where are you finding 168 from? On the decision node. I can't see one. Okay, number of samples 168. The one at the root node. That's very true. And that's what we are saying. See, at the end of the day, we are making decision of either this class or this class. So how many went to this class and how many went to this class? Okay, so in this case, the majority of which they were sampling went to this class. Then you also start another decision again. How many went to this class and how many went to this class? Okay. Then the sample 736 and this 10 to 94. This is okay. I get your point, but it's not as direct as what I wanted. Ah, this is it. Let's use generative AI. Once you built a model, why was I forgetting that? So I've saved this as decision3.png. So you just come to, let's say, Gemini. This thing produces. I use it to generate images for my site. Very clean image. Very clean. Market shade shop, market shade AI microservices, decision3.png. Here it is. Given the attached file, kindly help us make stakeholder report for the model on the decision, not for the on the. Just try to give it as much as information as it may need, and remember, as you give it that information, it is also picking, it's also learning from you. Yes. So with that information, it is able to show us. Wait for a few minutes. Analyzing. Here is the stakeholder report provided on the provided decision tree and a company code output. Maybe you are doing it for marketing, product development, customer retention team. So let's pick the customer retention team because this is the best person. You have prepared it, your name, executive summary. Yani wameenda official kabisa. So the executive summary, this report represents the finding from a decision tree classification model aimed at identifying key factors contributing to customer churn. The model was trained and evaluated using historical customer data. The visualization of the decision tree along with performance metrics provides actionable insights into customer behavior patterns. So it achieved the those scores: good ability to predict churn with room for improvement, particularly in identifying all factual churners. You see what I just explained? They are also doing the same thing. Remember, I told you yes, we could deploy that, but monitor, because at the end of the day, it can work poorly on the local environment, but and again, you surprise that in the underfitting, surprise that in the production environment. So the data was split, model selection, and decision tree classification was chosen for its interpretability, then hyperparameter tuning. Grid search CV was used to optimize the decision trees parameter to achieve the best performance. The best parameters were maximum depth of 3 and minimum samples of 2. The model's performance was evaluated using a stakeholder report. But then you are supposed to do this in your work, especially after building the model. You are now taking the report to a relevant team, which should actually use it to for their own purposes. They should know how to handle customers. Yeah. the, if there is anything that is entrenched inside business, is data science. Yeah, it's used to make the decision for the need. This means the model correctly, yes, predicted churn or no churn for approximately 79.4 of the test customers. Out of all customers predicted to churn, 65 actually churned. This indicates a moderate level of false positives. That is a bad number. The model correctly identified 49.1% of all customers who actually churned. This suggests that the model is missing a significant portion of actual churners, false negative. This is the harmonic mean of precision and recall, providing a balanced measure for the model's performance. This one is the metric that distinguishes model's ability to distinguish between churners and non-churners across possible classification. And 82 inamaanisha imejaribu sana. No, we wanted it to explain the decision plot. You can have that one as a PDF and send to the stakeholder, then you will be called to a board meeting to explain the results. So this is it. Explaining what each box or node represents and how decisions are made. So the plot visualizes the top 3 levels. So I'm going to put it in an there, there. Nice. So I hope you can strain and see. Yeah. The plot visualizes the top 3 levels of the decision tree. Each box represents a node in the tree and it contains specific information. Of course, you now know there is root node, decision node, and lastly the leaf node. The condition. The decision tree rule that determines which path to take, left for true or right for false. The Gini impurity, a measure of how pure the node is. A Gini of 0 means all samples in the node belong to the same class or perfectly pure. So inamaanisha we always tend to find the the least Gini because it's of 0 means all samples do not belong to the same class have been correctly classified. So samples, the number of training samples that reach this node, and also a value, a list showing the distribution of classes within that node. No churn count or churn count. So churn, no churn count is 41, 39. Churn count is 14, 95. So something like that. Then class, the predicted class for the majority of samples in that node. So the predicted class for the majority of the samples in that node is the class of no. So if you start, if you look at now the samples, the number of training samples that reach this node, how many training samples reach the root node? No, in the image. Yeah. Okay, let me just open it. Can you now see it? So, so that's the number of samples that reach that root node, the 56, 34 samples. Then we are being told no churn count and churn count. No churn count are 4139 and churn count is 1495. Then the majority of the values belongs in the class of no, so the no churn count. Yeah. So that's the as far as root node is concerned. Then the Gini impurity, a measure of how pure the node is. A Gini of zero means all samples in the node belong to the same class or perfectly pure. So if you look at this, of course, the Gini of 0.39, we do not, we've seen the values, how they, the discrepancy between the values. So probably we cannot say that these samples are belonging to the same class. Others are no chan count and others are chan count. Then we also have the first one, condition, the decision rule that determines which path to take, left for true or right for false. And this is now the tenure. Tenure, if it is less than or equals to 16.5, this is the decision rule uh, that that makes us make a decision. For example, did this guy, if he was in the company for less than 16.5, then if it is true that he was in the company for that all these years, we take this path. If it is not true, we take this other path. Again, when we reach the decision node, the second one, we now start again with the condition. Now the condition becomes internet service fiber optic. This guy, was he using the internet for service, the fiber optic one? If it is true, we will take left. If it is false, we'll take right. Again, the gene of 0.2 and samples that reach this node is 3592. What do you realize about samples as you move down the slope, down the depth of the tree? They keep on decreasing. Again, if you do that, the contract 2 years. If it is true, we move on to the contract 2 years. If it is true, then the leaf node is now where we make the best decision. Aya, how do you explain the leaf node is the one that gives us the answer? How do you explain the leaf node? The leaf node, you look at the values. We said the values is a list of the classes. So if in this case we just have yes and no, no chan count and chan count. So no chan count is 934, chan count is 106. Ndio. Then the majority are in the class of no chan count. Now after that, you now look at the average decision that are actually carrying the day. Ukiangalia hapa nodes ziko ngapi in the leaf nodes? And against yes, how many yeses do we have? So the no carries the day, and therefore, but that's not the pure explanation. The pure explanation is when someone of the tenure 16.5 is less than 16.5, and is true, by the way, someone who has been in the company with the tenure less than 16.5 and has used the internet service optic provider at a level of 0.5, and the tenure has now been reduced to 3.5. Remember, you can reduce the tenure the way you want to based on your analysis. This person is likely not to churn out. But if we move this person is likely to churn out. And what happened? This guy has been with the company for less than 16.5. Less than 16.5 inamaanisha hata hii tena nyingine 3.5 bado iko chini yake. Yeah, it has been with the company for less than 16.5. It has been using internet service fiber optic at a level of less than 0.5. Then it has been charged less than $120. At the end of the day, he left. This that's what the decision tree is actually entailing. Yes, and the decision tree just tells you a high level overview. But now it will be narrowed down to a single client. And when we now reach the single client, so let's see what the GNI codes. I don't know why you've let have fallen in love with Gemini. They are giving me results I really need. So like the tenure, this is the starting point of every customer. The first decision based on the tenure, how many months the customer has been with the company. The tenure has been less than or equal to 16.5 months, the customer goes to the left child node, true branch. If it is greater than it goes to the false branch. So it is the condition that makes us base the decision whether going to go to the left or right, and we evaluate it to true or false. Nakumbuka our theoretical approach is rainy or not rainy. Yeah. The Gini indicates a relatively mixed group of channels and non-channels at the start. So we cannot say that they are in the same group. Actually, 47.3 is always almost the same. Is almost equal. So in karibu zitashane. All 5634 training samples begin here. Out of these samples, 4115 did not churn out and 148 did churn. The majority of the class, of course, as you can see, did not churn out. Then the child node. As we move now to the Mhm, mhm. Mhm. Yeah. Gini ranges from 0 to 1. So 0 says that that's a pure class. You are able to classify correct that all the samples in this decision in this node, this is a node. All the samples in this node will be belonging to a one class, a pure class of no's or yes. So as you move all the way to 1, inamaanisha that majority will be on the other side of the valley. Remember, our main aim with the churning out is to look at how many people churned and how many people did not churn. So as you move further to 1 denomination, the value keeps on changing position. So if 0 was did not churn, 1 will be the all of them in this node churned out. So in short, Gini of 1 indicates a bad result that we don't want to see. For example, the client did churn out. Genie of 0, a pure class of they churned out. They did not churn out, sorry. Genie of 0 is the best, that is. And it shows a pure class of that, they did not churn out. Again, we do the same thing for the fiber optic, and we move on to the internet service fiber optic until we find our best result. Aya. Now, this is a high level overview. I implemented a low level overview with just one client. So I simulated one client to do this, and what new client? What happened to him? We are classifying a new client. First of all, we define a function to do that, and this function will take all the values that are needed for the x values. So you see, for you to classify, you must bring in the exact x values from the data frame. Remember when we were building the model, we split the data into x and y. For x were independent variables and y was the response variable. So x were used to predict y. So if you are to classify a new input or predict a new input, you must get exact values for x. Not necessarily exact in the sense of the value set, but I mean the structure must be the same. So in this case, we are going to have two functions: the input model and the decision tree model. The input data. The input data is the one you are going to enter. Unaona hizi the decision tree, the tenure, the internet service provider as fiber optic, and the total charges. These are what are called input data. Are we together? Tuko pamoja hadi hapo? Ama need to then the other argument is the decision tree model that we built up there. So for the decision tree model, it remains. So the decision tree model is going to be evaluated against the input data. And the thing explains well. Classify new input data using all decision tree. Okay, nilifanya mara moja using the decision tree model. The input data will be a dictionary with feature names and values. First of all, we first find the input. We first change the input data. Of course, we are going to you see, you are going to see a sample input here. Tunarudi hapo. Client akipeana input data yake, ama the model has picked up a new value that has come into the database. It will pick it na tuone, as time goes by, tuone how many years this client is going to be with us. The first thing is to do is to change it into data frame. Then you ensure all categorical features are one hot and coded. Then after that, you get dummies for all the input df. Or if and only if the column is a categorical column. Then align with the training columns. Input data, input df.reindex, columns equals to x columns, field values with 0. This is to say that the training columns will be the x columns. Then we now predict based on the input data. And we return the decision tree yes if the decision prediction is 1, or else if it is not. If this one cannot be realized, the logging will lead to an error. Unfortunately, there was no error, so it was realized. This function can now be used with the new data altogether. What do? You just get the new input data, example usage, and this input data, gender is male, senior citizen 0. In short, in a copy, gender, senior citizen, partner, everything, it must copy. Inaitwa simulation. You must try to simulate the data. This one is just for your testing purposes. You're just testing, not that is the real one. So the real one will be in the database. Yeah, so this is for testing purposes. So predictions is equals to classify new input, sample input, DT model. Then if predictions are right, if prediction is true, and prediction is true is when you actually have this function here na ukaweka the input data. Remember hii data tulisema ikishapeanwa, it will be changed into data frame. Then the categorical features will be one hot and coded. Then the categorical features that has been one hot and coded will now be assigned dummies. Then we reindex the columns so that X columns alone are used for training the data. Unaona? So at the end of the day, if the prediction is correct, we are able to put the sample input data into our machine here. This is a machine. What should we do? And also implementing the DT model. Na DT model tulishafanya vizuri hapa juu. Ndio hii. Sasa hapo hatuna kitu tena tunafaa kufanya. Then print the sample input predictions. Then for model and prediction in prediction.items, print model and the prediction. The decision tree has predicted that this guy will not churn out. This guy here. So you can just play around. You can also change things around, then run until you find yes if the guy will churn out. Remember that the results you are finding here is at what percentage? At 78.71 accuracy. This is a high level, but this one is a broken down example. We save the model for production, and lastly, we will now do some things during production as time goes by. So I think it's in the random subforest classify. Please, is there any question? So you have a lot to do, by the way, especially. But anytime you need the codes, it's just one thing. But I really encourage students waziandike. Mimi napenda sana mkiandika. So I also used to do that. I built this, by the way, in a Google certificate, Google Data Analytics certificate from Coursera. One day after you're done with all these, you can also just try and seeing how they do the thing. We are now moving on to the support vector machine. Time ni 12:10. Nitakwenda mbio. So thank God I'm not going to explain pre-processing and splitting the data. The only thing I'm going to do now to scale the data. Why do we scale the data in support vector machine and we not do that in decision tree? We are we are scaling the data in support vector machine because as you can remember from the theoretical approach, support vector machine was actually trying to find to reduce the margin, to increase the margin, the hard margin, that is. So it was trying as it would to increase the margin. And the formula was a mathematical formula that worked well on a continuous data. Since our data set mostly contains categorical data, it means that for us to calculate that margin, we must scale the data is when we can find that margin. Yeah. So scalar is standard scalar, just calling the standard scalar from sklan. Then xtrain scale, scalar.fit transform on xtrain. Then xtest scale, scalar.transform on xtest. Look at that. On xtrain you fit transform. On xtest you just transform. Again, you use grid search CV2. You use grid search CV2 to find the best parameter tuning. Hata ushaona. But I wanted to ask, can you remember the hyperparameters we talked about in support vector machine? The C and the kernel, the linear kernel and radial based function kernel, the RBF. So the grid search you will be able to find based on our data which one is best. C was the C was actually the hyperparameter that was used to smoothen the margin. Do you remember it? So and we said it is always either 0.1 or it is always 1.0. So here we are introducing another value of 0.1 and 10 to ensure that maybe during parameter tuning, we find the best one that can smoothen the margin. Remember, our main aim with support vector machine is to have as large margin as possible, the hard margin to be as big as possible, so that these items are separated. The classes of no and yes are separated accordingly. But now the support vector parameters, the support vector parameters are the C and the kernel. We will be able to choose from using grid search. We'll be able to choose from this and this on iteration. So the support vector machine grid, we now just implement SBC probability equals true, random state is 42. So this is again you can find this on sklan SCV. If you just come to this guy, I mean the source of all truth lies here. So the support vector machine, the C, you see the default is 1.0 regularization parameter, the one that regulates the margin. The strength of the regularization is inversely proportional to C, must be strictly positive. The penalty is a 12 squared penalty. You have the kernel. Are you going to choose linear, poly, RBF, sigmoid, or pre-computed? And by the way, you are allowed to, we mostly use linear and RBF, radial based function. And I think radial based function works best. But again, we are not ruling the fact that linear can also work on the same thing. We also have others like shrinking the probability, whether to enable probability estimates. This must be enabled prior to calling fit. We'll slow down that method as it internally uses five-fold cross-validation. But the best part, whether to evaluate, to enable probability estimates. So if you do not want the exact estimate, you want to use probability estimates, you can choose probability to be true. And that's what we've done here. You see, these parameters are too much. So most of them we just during the data scientists at Scikit Learn were actually able to sit down and find the best one that can work with a wide range of data sets. So the one that you feel like cannot work with the wide range of data set for your case as a data scientist in a different business entity, you just do hyperparameter tuning using grid search. So in this case, we fit X to train scale and Y train. Then we find the best estimator. And we said, how do we find the best estimator? The best estimator is actually the estimator from the grid search results. And we will predict it accordingly. And when we come that, the best estimator was the one with the C of 1.0 and the kernel radial based function. And it gave us an accuracy of 79.28. Not bad. Then we can now do the same thing as we did with the classifying the test, sorry, using support vector machine. Exactly the same data. Support vector machine. Look at that. No. This is like now from here to here is basically what we did with the decision tree. Now let's see ensemble learning how it's going to work for us. Ensemble learning is the random forest classifier. The random forest classifier also work in a similar way, except that in this case we now ensemble different models where one acts as a base learner and the other one acts as a meta. So let's see the models that have been used in this case. Preprocessing, not my work. Splitting, no. The random forest classifier. Aya. What did we say about random forest? We said it works by splitting the training data that had been priorly split. So tulishai split hapa tukakuwa na hiyo data I guess ni 5634. Random forest is going to split this into how many estimators, into how many number of sample split, maybe 2 or 5. So it will be between 2 and 5. So if it's split into 5, it will be 5634 divided by 5. Into 2 will be 56 divided by 2. After the random forest has done that, it will use a base learner, which is a decision tree. And that's why the decision tree will now be maximum depth of 5 or 10. And number of estimators. How many estimates are we going to do on this case? We are going to use 100 or 200 estimators for the random forest parameters. From our theoretical approach to random forest, we said, and you saw from that diagram, that the large sample, the training data is up here. Then we split it into different samples, if it is 2 or 5. Then we implement decision tree on each and every sample. Please, wacha tuende huko. Mm-hmm. Vector, random for okay. The base, they're called base learners. So we said random forest works best. It's basically an ensemble of so many decision trees. Remember me saying that that's why it's called a random forest. So if you are using a new, you will see. If you are settled on another one other than a decision tree, you will see it now doesn't become a random forest. It's a new model altogether. And other models that you're going to look at are cascading, voting, and everything. So in this case, random forest is only for decision trees. Yeah. The decision trees are the base learners. In short, let me say that. For random forest, the decision trees are the base learners. That's a very good question, by the way. It opens slowly like my wallet nowadays. tutamaliza hizi slides. Here we go. The regional training data, we have the samples. In this case, we want to choose whether there's two or one. Then look at this. We have sample decision tree 1, decision tree 2 on the sample 2, decision tree 3 on sample 3, decision tree 4 on sample 4. Then the next thing, what do? We find the aggregation of all these. Then that makes us, when we do the aggregation, that is what we refer to as the meta learner. So at the end of the day, we find the best prediction. So when we go back to our work, that's exactly what is being implemented here. But again, you can always be guided by AI and also the Science Learn, a very powerful package for that case. So the research is going to help us identify the number of estimators, or I don't want to work on any on theory alone. We also look at practically. Yeah, the number of estimators. So just look at all these arguments or parameters. So when you have time, you will come and read what they entail. So the number of trees in the forest, that is to say, remember what we said. Remember what we said, that in random forest, it's a form of bagging, and bagging is bootstrap aggregating, which is carrying out sampling with replacement. So when you do the sampling with replacement, you implement a model. When you replace, you implement a model. So the number of decision trees that you're going to implement are are between 100 and 200. So the default is always 100 in the forest. So then we also have the maximum depth of the tree. If none, the nodes are expanded until all leaves are pure, or until all leaves contain less than minimum sample split. So, and that's why you see now the random forest has just introduced this long mini, but mostly it has borrowed heavily from the decision tree. That's why I was saying it's the random forest is basically decision trees acting as the base learner, and at the same time the decision trees are the meta learners. So you're just using two or more decision trees on the same models to improve accuracy. And we want to compare, you are going to compare the accuracy score here with the one in decision tree. I bet you there is no single day the one in decision tree will be larger than the one in random forest. So the implementation logic remains the same. The only thing that might have caused some nini is here, some confusion. So everything remains the same. And look at the accuracy, 80%, which is higher. Yes. So the feature importance for random forest, the feature importance is basically features in machine learning. Remember from the word feature engineering, we say that the feature is basically what is contributing to the model, the column that is contributing to the model. In our case, the columns that were contributing to the models were the X columns. So that is the feature. And as you can see, we are changing this into a data frame. Then the importance is the random forest model dot feature importance. The feature importance, this one, like the plot tree in decision tree, this is the one that is able to explicitly pull how different features contributed to to the model being at 80%. Are we together? And you're going to see it in a graph wise. You're going to plot it and you're going to see which feature actually made us realize the accuracy score. Then we sort the values by importance. Ascending is equals to false, meaning in descending order from the highest to the lowest. Then random feature importance, top 10. Then you print the top 10 features. You can also plot them. The top 10 features are tenure, total charges, all the way up to paperless billing. And now when you plot them, here is what we find. And remember, some of them we did a one-hot encoding, like online security, yes, it's a feature. So, but most important is that the tenure of the guy is the one that tell us if the guy is going to churn out or not. The confusion matrix for a random forest. I just put y test against y prediction, and as you can see, no against no for actual against prediction worked best, and also so no against no, like those guys who are predicted to not churn out actually did not churn out a majority. So that is the best thing that happened in the decision tree. When we classify classification, I think it's with you that we also did some feature importance back then using, was it like k nearest neighbor or neighbors? There is one we did feature importance to evaluate how different feature contributed to the model. Well, this is very important for a stakeholder. You will be able to know, as you can see, the total changes that the person uses on our services is likely to influence whether you churn out or not. Then, at the end of the day, we classify, and when we did classify, it was still no. The only difference is that the accuracy increased. That marks the end of today's lesson. We've done a lot. The video, the best way to use it is basically to pause, and if you don't get anything, you just come to msema kweli wetu hapa. This is where we base all our arguments. So we will start with AdaBoost classifier next time. There is also XGBoost, but in short, what I'm going to say is that we are now going to finish on ensemble learning. The first one was bugging. The next one will be boosting, and you'll see how boosting works. Yeah, then the next one, boosting ni optimizing. It came to optimize. It is actually just optimizing bugging, and we'll see how it is done. Then we also have algorithm under boosting, AdaBoost, XGBoost, gradient boost, cut boost, light GBM, and you will see what they mean there. Then we'll talk about stacking, then blending, then voting. After we're done with voting and cascading, that's when we can now talk about easy pressure finance, so we will not repeat. We can now talk about unsupervised learning technique. So we still have 1 week. I really wanted us to finish with, before we go for our midterm. That's our is tukuwe tumemalizana na hii mambo na nini unsupervised, so tukirudi tukuje to pick up from uh, 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 reinforcement, then last deep learning. And like I said, reinforcement hatutaenda deep sana. Yeah. Yep. That marks the end of today's lesson. Thank you for joining today's class. Unless you have any other question.